Unit 9, Day 3 notes. Today we're going to be discussing rectangles, rhombi, and squares. Rhombi is plural for rhombus, FYI. So the first thing we're going to talk about is rectangles. So make sure you draw a rectangle beside the description on your notes, like I have. A rectangle is a quadrilateral with 4 right angles. So let's draw our 4 right angles. Next thing we need to make sure we make note of is a rectangle is always a parallelogram. So all of the properties we talked about last time hold true for a rectangle as well. So in other words, that means both pairs of opposite sides are parallel. So the 2 short sides are parallel, the 2 long sides are parallel. Also, both pairs of opposite angles are congruent. So as you can see, my opposite angles, this angle here is congruent with this angle here. This angle is congruent with this angle. Technically, they're all congruent with each other because they're all 90 degrees. The consecutive angles are supplementary. So again, the supplementary angles are going to be top left and bottom left. And top left and top right are supplementary. Also, I need to mention that both pairs of opposite sides are not only parallel, but they're also congruent. So let's add tallies on the 2 short sides and tallies on the 2 long sides. They're congruent. So the diagonals will bisect each other. Just like a parallelogram. So this would get 3 tallies, and this other side would get 3, and then this one would get 4, and this one would get 4. So that's what it means to bisect. Cut each other into 2 equal parts. But the last line is special to rectangles only, so we're going to highlight this line when we're done writing on it. But you need to know that the diagonals are congruent. So this last line or statement, again, is special to rectangles only. So rectangles' diagonals are congruent. So, in other words, instead of having three tallies on two parts and four tallies on the other part, I can put them all to have three tallies. Dang it, I put four again. Make two, three. Alrighty, so that's everything about rectangles so far. Now we're going to talk about the rhombus. The rhombus is a quadrilateral with four congruent sides. So all four sides get a single tally because they're all congruent. A rhombus is always a parallelogram, meaning opposite sides are parallel. So let's mark that as well. So arrow, arrow, arrows, plural, and arrows, plural. Those are the opposite sides, and those are the sides that are parallel. Also, opposite sides are congruent, as we've already mentioned. And we've already illustrated. Both pairs of opposite angles are congruent. So this angle is opposite of this angle. So the top and the bottom, according to my picture, yours could be drawn differently or drawn exactly like mine, totally fine. And then that means the left angle and the right angle are opposite of each other, so they're congruent. Again, consecutive angles are supplementary. So the two supplementary angles are going to be that top one together with one side. Those are supplementary or consecutive. Or you could use the top one with the other side. Those are supplementary. Just remember again, consecutive means same side and side. And then the last thing that is same for all parallelograms is that the diagonals bisect each other. So I've already used single tally, so this would be double, double. This would be triple and triple. Or you can actually use numbers. Now some other information that is specific to only the rhombi. First one being that the diagonals are perpendicular. The diagonals are perpendicular, so they form four 90-degree angles. Also, the diagonals are going to be angle bisectors. So the diagonals split these corners into equal angles. So again, these attributes are specific to only the rhombi, so let's highlight it. So a rhombus has four congruent sides, diagonals are perpendicular, diagonals are angled bisectors. This is for the rhombus, though specifically and only. Now, let's talk about the square. So draw yourself a square. A rectangle, a square is a quadrilateral with four right angles and four congruent sides. So that being said, a square is always a parallelogram and a rectangle and a rhombus. So everything that I have said in the previous day as well as the previous two sides are true for a square. So you can mark up the picture or just remember that these sides are parallel. These diagonals are congruent. The diagonals are perpendicular. They get that from the rhombus. Also, the diagonals bisect. So all of these right angles become itty bitty 45-degree angles. And I believe that covered it, with the exception of the consecutive, which is should be self-explanatory. If it's 90 and 90, it's going to equal 180. So that's everything about the rectangle, rhombi, and square. So let's practice a few problems. So number one and number two have to do with this rectangle on the left, rectangle ABCD. Number one says if BE is 6y plus 2, if you want, you can label that on the picture. Well, rewind. Since it's a rectangle, let's go ahead and mark the rectangle and all of its congruent parts. So we know it has four 90-degree angles, right? We know that the opposite sides are congruent. So BA is congruent with CD. BC is congruent with AD. We also know that the diagonals are congruent. So that means these pieces AE are congruent with EC, which is also congruent with BE, which is also congruent with ED. Okay? So now that I know that, let's highlight the specific one that they give us. So they give us BE is 6y plus 2. They also give us CE, which is 4y plus 6. And they want us to find y. Well, based on how I marked the picture up, I know that BE is congruent with CE. So that means 6y plus 2 equals 4y plus 6. And now I can find y. So I would subtract 4y, get 2y plus 2 equals 6. Subtract 2, I would get 2y equals 4, and then divide both sides by 2. So y equals 2. Alright, for number 2, it tells us the measure of angle BEA, so let's highlight that on our picture. If I trace it, BEA will be this angle here in this corner. It's 62. It wants us to find the measure of BAC. So if I trace it, B to A to C will be this angle in this corner. Now, this is an isosceles triangle BAE. I know it's isosceles because it has two congruent sides. So since it has two congruent sides, that means angle BAC, what I'm looking for, is the same measure as angle ABE or ABD, however you want to look at it. In other words, if I call this green one X, this one on top of it will also be X. So I could say I have 2X plus 62, and that's going to equal 180 because I have a triangle, BAE, right? So if I subtract 62, I would get 2x is equal to 118. And then divide both sides by 2. You would get x is equal to, is it 54? Or 64? No, I think it's 54. 59. My bad. A little off. So in other words, the measure of angle BAC is 59 degrees. Alrighty. So on number 3 and 4, we're going to use rhombus ABCD on the right. So since it's a rhombus, let's mark up all the information we know. We know that all four sides are congruent. We know that the diagonals are perpendicular. So there's 4 right angles, even though I'm only going to draw 2. We also know that the diagonals bisect each other. So these two angles are the same, these two angles are the same, and then these two angles are the same. Or 4, should I say, since it's 4 little angles. So those are the specific things to a rhombus that are slightly different than a rectangle. So now let's highlight the information that we were referring to in this problem. So ABD, let's trace it. A to B to D is this angle in this corner on the left, top left. It's not the entire angle, it's just that small one. That is 60 degrees. It would like for us to find angle BDC. So when I trace that, BDC is this angle right here. Well, thankfully I marked the angles prior to answering this question because, as you can see, those two angles are marked the exact same way, meaning those two angles are congruent. So if ABD is 60, then the measure of BDC is also 60. Next thing I'm looking at are AE and AC. AE is right here, and then AC is the whole part, or whole diagonal. It's 16. So we know that the diagonal is split into two parts, right? And this part is 3x minus 1. So that means this part is also 3x minus 1. So in other words, I could say 2 times AE is equal to AC, right? Because I wrote it twice. So that's 2 times. So that's 2 times 3x minus 1 is equal to 16. When I take 2 times 3x minus 1, I would get 6x minus 2 equals 16. Then I would add 2 to both sides, which would give me 6x equals 18. And then divide both sides by 6. So x equals 3. For the next few, I will help you mark up the picture, but I would like for you to answer them on your own. Since it's a square, we know that all 4 sides are equal. We also know that all parts of the diagonals are equal. We also know that the diagonals are perpendicular, so we add our 90-degree boxes. And the diagonals bisect each other. So there's several little 45-degree angles around in each corner, FYI. Now that you have the picture marked up completely, please answer each one of these questions. And they tell us the distance from P to Q is 8 in the passage. So that should also help. Again, good luck on finishing the rest of these notes.